Hey guys, so today we're going to talk about pages 618 to 621. So make sure you have your pencils and your highlighters ready because we're going to get on a roll today. So I'm on page 618, 618. So 618 and 619 are all about separating mixtures. Okay, I'm going to start, so I need you to bear with me. Suppose you really don't like olives. I don't like them. How are you going to get them off that deluxe pizza your friend ordered? Sometimes you need to separate the components of a mixture. Now, with your pencil, I need you to underline active reading. As you read this page, put brackets around the sentence that describes the problem and write P next to the sentence. Underline the sentence that describes the solution and write S next to it. Yes, I know you can already see my letters. That's okay. So, I'm going to start reading the paragraph, and I need you to follow with me. Mixtures are not always easy to separate. But since mixing is a physical change, each component in a mixture keeps most of its physical properties. Physical properties such as color, size, melting point, boiling point, density, and ability to dissolve can be used to separate mixtures. Separating a mixture can be very simple, or it can involve several complex steps when one method is not enough. Okie dokie. So, where do I need to put the brackets around? Think back to that active reading. If you said, right after separate, I'm going to put it in red. And right on this M, that's right. So you need to write the letter P next to mixtures are not always easy to separate. Good job. Where do I need to underline? What sentence do I need to underline? I'll give you a second to think. Yes. So I'm going to underline it in green. That way you can see it easily. Physical properties such as color, size, melting point, boiling point, density, and ability to dissolve can be used to separate mixtures. Good job. And you're going to write a little S out to the side of it. That way you know it's for, what is it? Yeah, solution. We have our problem and solution. Okie dokie. So let's look at the example to the right. Density, it says. So every substance has its own density. A less dense substance will float on a denser substance. I know that was a lot of S's, but bear with me. In yellow highlighter, highlight objects will float in water if they are less dense than water. Put your yellow highlighter down. And pink highlighter, they will sink if they are denser than water. I'm so sorry about the faucet running in the background. That was my friend Brittany washing her hands. Okay, let's move on. So, in the little white box, it says what property was used to separate the items on this tray. So, if you look at the tray next to it, there are marbles, which are circular, and the cubes, which are squared. So, I am separating these two items on this tray. What is it that I need to classify them as? Now, with your pencil, I need you to put a star next to this box because that is what you will be answering. Okie dokie, let's move on. Now we're on page 619. I'm going to kind of go through this, so make sure you have your highlighters ready to go. Okie dokie, when one isn't enough, this is all what this is about. So, your mesh screen. So, this is kind of what we're looking at right here, this little circle. Okie dokie. In pink highlighter, a sieve or mesh screen has holes that matter can pass through. That's in pink highlighter. Matter that is smaller than the holes passes through the mesh screen, while matter that is larger than the holes stays above the mesh screen. So, if you've ever used like a strainer of some sort, let's say you put macaroni into a strainer and you're getting the water out, that's essentially kind of what this mesh screen is. Just to make it more physical for you to think about. Okie dokie. So, magnetic force and pink highlighter. A magnet attracts matter that contains iron. That's in pink highlighter. Now put it down. Separating it from the other parts of the mixture. So, this is what it's talking about right here. Okay, filtration. Right here, people. Filtration. So, a filter works like a mesh screen with very tiny openings or pores. In pink highlighter. Only the smallest bits of matter, like water particles and dissolved particles of salt, can pass through the pores. Okay? So, make sure you highlight in pink that part. Okay, evaporating and boiling. So, that is all what this is going on right here. So, in pink highlighter, boiling is when a liquid rapidly changes to a gas at the boiling point of the liquid. That's in pink. In yellow highlighter, evaporation also changes a liquid to a gas, but it occurs at temperatures below the boiling point. That's in yellow. In orange highlighter, during these processes, only the liquid particles leave the solution. Dissolved particles stay behind. That's all in orange highlighter. Now put it down. Now, you're probably thinking, why does this even matter? Or why do I really need to know this? Now, I'll tell you why. It's important to know how to separate mixtures because one day you'll probably have to understand the process behind it. So, for example, looking at this water down here on the burner, so the water is boiled away and only salt is left behind. So the goal of separating salt water would be to find one of the two properties that was combined to make salt water. Does that make sense? Okay, so let's go ahead and move on from these two pages. Now, really quick before I move on to 620, I just want to go back to 618 really quick, because if you look with the density and just trying to find, what is more dense, the goal of that would be finding which object weighs more than the other. Because if it's less dense, it's going to be able to float. If it's more dense, it's going to go bloop down to the bottom. Okay? Does that make sense? I sure hope so. Let's go ahead and move on. Now we're on page 620. This is all about proportions and properties. 620 and 621 are. Okay, have your pencil and your highlighters ready. So, let's start. When you make lemonade, it's important to get the amounts of lemon and sugar right. If it's too sweet or too sour, it doesn't taste right. So, in orange highlighter, how do proportions affect the mixture? Let me read that again. How do proportions affect the properties of a mixture? There we go. Okie dokie. So that's an orange. So put your orange highlighter down. Okie dokie. So I'm going to start with mixtures. I need you to stay with me. Do not highlight ahead of me. Okay, in yellow, mixtures of metals are called alloys. Okay, put your yellow highlighter down. The properties of the alloy depend on how much of each metal is in the mixture. Chemists, in pink highlighter, first decide on the properties they need their alloy to have. Put your pink highlighter down. Then, this is an orange highlighter, then they decide how much of which metals will give them those properties. Put your orange highlighter down. Steel is an alloy. It is made from iron and other substances. Different substances give steel different properties. For example, in yellow highlighter, adding chromium will make steel shiny. Put your yellow highlighter down. In green highlighter, metals such as nickel and titanium can keep it from rusting. Put your green highlighter down. In orange highlighter, carbon is often added to steel to make it stronger. Put your orange highlighter down. Other substances help steel used in tools stay sharp or keep from wearing down. So in yellow, tools stay sharp or keep from wearing down. Put your yellow highlighter down. Okie dokie. Now, in this example below, to make an alloy, metals and other elements are melted together and then allowed to harden. Okay, so I want you to put a star with your pencil next to this because that's super important to know. Okay, so bear with me. We are going to circle some words just so you have an idea of what to remember. Okay, so first, whoops. First, it's important to decide what they have to have, okay? And then, so that's their 2 steps. You got a 1, 2. Okay, make sense? So from here, in your pencil, okay, I want you to circle the word shiny. You're going to underline can keep it from rusting. Okay. You're also going to circle the word stronger. And last but not least, you are going to completely underline this bottom yellow statement. So before we completely move on to the next page, I just want to make sure everybody understands that making a mixture is not a chemical change. Now say that again with me. Making a mixture is not a chemical change. Okay? So what we would be doing with this is not making a chemical change. Just keep that in mind. It is not a chemical change. For instance, let's say we made a steel kettle just out of the blue. Now, we would have to add something to make it shiny. So what we would do is we would add chromium to the steel to make it shiny. Now, if I were to, let's say, make a steel sculpture, I would want to add carbon to the steel to make it stronger. And that way, I would also add nickel and titanium. That way it doesn't rust or get damaged. Does that make sense? And let's say I was watching some people build a steel frame of a new building. Okay? I would also want to see that it's, strong. And what do you add to steel if you want it to be completely strong? You add carbon. Now, do I add a ton of carbon? Not really, because it still has to be flexible enough for it to be able to move without the wind breaking it. Does that make sense? Okay. It'll make sense here in a second. I sure hope so. Okay, I am on page 621. You can take your blue highlighter, people, and you can make a big X over do the math. Woohoo! No math. What up? Okie dokie. And pink highlighter. For each steel object on this page, list at least 2 properties that the steel must have. Okay, I want you to circle the word 2. Most importantly. Now, on your paper, next to kettle, sculpture, and steel building frame, I have already written 1 and 2 on my lines. I need you to take 3 seconds and do that for all of yours, okay? Okie dokie, I sure hope you've written those down now. So, let's go through these really quick. I'm going to give you one extra on each one, okay? So, I'm going to do 3, the third one for you, on each one, okay? Just so it can make sense. So for a kettle, I know it can be shaped. So I'm going to write the word shaped. Sorry, that's a one messed up A. Okie dokie. Now for the sculpture, what is something that you could do with the sculpture? Yeah, that's easily shaped as well. So I'm going to write easily shaped. SHAPED. And for the building of the steel frame, for number 2, I'm going to write flexible. Okie dokie. Now that you have that, you are good to go, and make sure you upload the videos And make sure to like this video.